Hello, 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 hello.
Yeah, bro. Exactly. Thanks, bro. But yeah, eventually then like it combined all of this stuff and it would like speed up the time for response for incident responders. But this ended up winning the grand prize for the best solution in 2017. And in GE, I presented this to the entire company. But yeah, that's where I got started out in like AI and stuff. But now, ready?
30 seconds. 30 seconds.
Okay. Countdown.
Go ahead.
Oops. All right. Are we ready?
Yeah.
All right. Assalamu alaikum, everybody. Thank you for joining. Today we're going to be talking about AI architectures. So right now, I'm sure you guys are familiar with LLMs. Like, how many of you guys use the LLM right now? Okay, probably everyone, right? Now, how many of you guys are familiar with what kind of architecture the LLM uses? What is it?
Transformer.
Yeah, exactly, transformer. So that's just one subset of the architectures in AI that's available. Who can name some other architectures?
CNNs.
Yeah, yep, yeah. We got GANs, we got RNNs, you know. But yeah, all of these have different like strengths and weaknesses. But right now, what's really been popularized is this transformer architecture. And I'm going to go over some of the pros and cons of that architecture, and then like talk about how we can improve that. So like, let's talk about the foundation. What is it? What is AI architecture? Like when somebody says AI, like, you know what I mean? For somebody who doesn't know like what AI is, like how do they understand it? So it's basically like the core components are going to be part of the data that is trained, the model that is the data is trained on, the algorithms that are used in order to process that data, and the infrastructure which the AI runs on. So it's really like a very advanced data classification problem, and it essentially takes these core components and makes them work together in a way that like it simulates intelligence, hence the term artificial intelligence. Now I'm going to be talking about how we can get from artificial intelligence to a term that I like is digital intelligence. I don't know if you guys have heard that yet, but I've been throwing that around in the conversations that I've been having with AI, and like I think this is like one of the first steps that we can take in order to get there. Like instead of having artificial intelligence, we're going to be replicating like the functions that go on in the brain. So let's talk about the current state. So the current state is, like you said, transformer-based architecture. There's also other ones as well, convolutional neural networks, recurrent neural networks, and then like all of these rely on like having a massive data set to train this AI. And it's just, we're essentially just brute forcing intelligence right now at this point. But that eventually goes like to a logarithmic like limit, where like you have the more data that you have, it goes like higher and higher in terms of the intelligence, but then eventually it tapers off. I'm sure you guys are familiar with like DeepSeek. Have you guys used DeepSeek yet?
Yeah.
Okay. What do you guys think of it?
Pretty good.
It's pretty good,
Yeah.
but it's yeah. I mean, they're all getting better every day, but marginally, right? Like there's still certain issues that we face, like especially those of us who are deep into it, and especially those of us who are using it for coding, like me. So I'm going to tell you guys like, I guess like the hierarchy of the transformer-based architecture. So in general, we have machine learning models like called the linear regression. You know, that's the primary one, which I was using back in 2017. And then also like there's support vector machines as well, naive Bayes. You know, essentially it's all just like some type of regression modeling. And then we have deep learning models like LSTM, and then we have transformer models like BERT, which is like pretty much what all these today's LLMs are based off of. And the pros are they're good at predicting the next token. So if you have like a word, then or a sentence like saying like whatever like it's like Mad Libs, right? You fill in the blanks, or then it predicts like whatever next like likely outcome is based on statistical models, not from contextual understanding. So that's bro. So that's one of the things that it's good at. It's good at processing text, and now we have multimodal models as well, where it's good at like generating images and processing images as well. It's versatile and it's pre-trained, so it's ready to go. Now, some of the cons are that it has this smart dumb problem, where, like, I'm sure if some of you guys, or if you guys are working in like programming, and especially in architecture, where you tell an AI to do a certain task, and it goes and it starts thinking about how to do this task and thinking about how to do this task, and it overanalyzes and overthinks, and then it does something really dumb. You know what I mean? In order to achieve the outcome, but like it doesn't actually achieve what you want. And then also another one is it has high cost. Obviously, you know, these AIs cost a lot, not only to use but to train as well, because of the massive amount of computation that it requires to build them. And then the context size limits as well. So not only do you have the huge like model size that you're working with that takes gigabytes and gigabytes of VRAM, you also have to take into consideration the context size as well. And context size essentially grows like exponentially. It's like O of n squared based on like the amount of data that you're putting in, and then it's going to eat up all your VRAM. So you're going to have to like either get more computation, or you're going to have to limit the model size that you're using. And then one of the big issues is hallucinations. Like, how many of you guys have had hallucinations in your AI work, right? It's annoying. So like sometimes the AI would just like come up with some random stuff, and I'm like, bro, like this sounds almost real, but if I didn't know what I was talking about, like I might believe you, but this is actually not what it is. So like that basically like factors into their limited reasoning capabilities. So this is some of the stuff that I want to address in this new architecture, and like hopefully we can walk through it. And if you guys have any questions along the way, just let me know. Before that, I just want to like touch on a little bit of the use cases that that I was like I guess exposed to and kind of like explore. Obviously, cybersecurity, since like, you know, I'm a big cybersecurity guy. I know there's a lot of other cybersecurity guys in here as well. Anomaly detection is a big one, where you have traffic analyzers and like your SaaS, I guess, monitors, where you're analyzing, okay, so like what's normal, what's baseline, and then if there's an anomaly, we'll detect that. And then in finance, we have like trading pattern analysis, which is one of the projects that I'm working on, which I'm going to introduce to you guys later. Healthcare, I most recently was working for a healthcare AI company, and pretty much like overhauled their entire cybersecurity like processes to get them from a place where they were like concerned about their cybersecurity like well-being to a place where they felt comfortable enough to let me go. And you know, I think that's like, you know, that means I did my job properly. You know, I'm not here to like stay around. I'm here to innovate and then do the next thing. So one of the actual use cases is like radio imagery like detection for cancers. And then there's also what I was working on is HRM, like insurance verification. So automating that revenue cycle process. And then lastly, I want to talk about robotics as well, because this is going to be the next big thing. And you already seen like robots out there that have like decent capabilities. I also have a robot as well I want to bring to this lab so that we can play with it. It's not as like robust as, you know, some of the stuff that they're making over there, but it's a good way to be able to combine the transformer architecture along with the neural networks to take in sensor information so that the robots can learn dynamically. And then I'll just wait a little bit until everyone gets situated to proceed.
Have you seen the robots that they've been hooking up to like ChatGPT? Like,
I've done that, yeah.
Okay.
Yeah.
Look at the yellow balloon tracking.
Yeah. Yes. It is actually pretty fun. I've been wanting to do that for a long time, and it was not until recently that I was actually able to do that. So I actually have a server that I host the server for the robot on, and I run the AI model on the server, and then like basically it like just rolls around and looks at stuff and it talks like as if it's like ChatGPT in a robot.
There's been a lot of papers in autonomous driving things, something like that.
Yeah.
Directed to ChatGPT.
Yeah, but it's not just ChatGPT though. It's just like LLMs in general.
Yeah. What models are you using?
The models that I'm using, I have explored with a couple different ones. Like right now, I'm using a multimodal model called Lava. So it's a mix between like Llama and another multimodal model. So it basically allows it to have like vision as well, so it can process images. Before I was using Google's Vision API in order to process those images, and then I would just get back like a tag, like of like text and stuff like that, and then I would do it based on that. But this is I think better because then it would have it in one model. So, all right, now on to the next frontier is like what I was mentioning, the neuro-symbolic hybrid. So this slide was actually generated by an AI when I asked it like what's the next, and it essentially kind of like simulates the architecture that I was going to be presenting. That there's actually already a paper about it. It's called HRM. How many of you guys heard of HRM? Hierarchical reasoning model.
Oh, yeah.
You have, right? Okay. So the neuro-symbolic hybrid is like a concept where it takes like a transformer, which basically processes like text and unstructured data, and then like a symbolic reasoning aspect of it as well. Like, so you can think about it as like a lower level processor and then a higher level processor as well. Or you can think about it from like a business perspective, like as like a worker and then like a CEO. So a worker just does the task, a CEO basically coordinates the tasks. So right now, in our interactions, we're essentially operating as CEOs. We're operating as like the directional like input, and then the AIs are essentially like doing the work. So in this hybrid architecture, you have the input, which is going to be the data, the neural network for processing the input data, and then the output is going to be a symbolic representation. How many of you guys heard of RAG? Retrieval augmented generation. And then, okay, so it basically, you're using a vector database and you're using embeddings to ingest documents, like whatever like information that you want to use to like enrich the AI's response. And you're embedding that in like a vector like knowledge graph type model where you're then feeding that into the AI, and then it's going to be outputting like a more intelligent response based on that. And then there's going to be like a logic engine, which is going to use this data and knowledge, and then it's going to take action on it. And then afterwards, there's going to be like a feedback loop saying that, okay, is the path that I took in order to accomplish this task valid? Is it working? And if it is working, then great. We're going to enforce that. And then if not, then we're going to adjust that. I'm going to come back to these two because this is a little bit more in depth, but this is just use cases with that. And I already touched a little bit about the robotics portion. But what I do want to touch on a little bit is BCI. So brain-computer interfaces, this is where we're going to get to the next, I guess, next leap forward. So before, when we had like enterprise computers or like mainframes, and then we had the introduction of the personal computer. This is kind of like as big as that, where we have like a different mode of interaction with computers, where we're not touching stuff. You know what I mean? We're rather than like interacting like physically, we're going to be interacting with our minds. And I do have a device that I've been playing around with, and I want to introduce it to this lab as well and like do some projects with it. And I want like some people who are interested to work with me and regarding that. And I have a whole project plan laid out where, okay, so first we're going to be using this to turn on and off lights with our mind. And then we're going to be using it to control a robot. And then we're going to be using it to control a computer. But using this new type of architecture, we can really tap into like using the BCIs more effectively. Because right now it's just rule-based system. So basically you have like a recording of a signal, and these signals are really noisy and complex because everyone's brain is different. And being able to apply that kind of dynamic AI structure on top of that, being able to learn somebody's patterns like dynamically, will then allow us to like figure out what kind of actions and intents somebody has, no matter what kind of brain architecture that they're using. So that's one of the, I guess, one the goals that I want to achieve with this architecture. But essentially now I want to like talk a little bit more about the lower and upper brain system, how we use it. So you're familiar with all the like the lower level brain, like limbic system and like, you know, subconscious and things like that, where it operates your breathing, your brain stem basically operates all your functions that you don't really have to think about. And like, you know, it's similar in all animals, but what separates humans is this meta representation portion here, which operates based on the prefrontal cortex. So this would be essentially the CEO level operator, and the rest of the stuff is basically like your like lower level like worker, right? So we control like how we're going to be moving our body. It's not the other way around. It's not our bodies controlling like how we're thinking. But I mean, I guess maybe it could be in like a feedback loop type situation. But yeah, this is taken directly from the paper, and I was reading a little bit about it, and it's a HRM 27M model. So it's 27 million parameters versus like, let's say you have DeepSeek, which is like 600 something billion parameters, right? So it's an orders of magnitude smaller. And then it can also, in terms of like certain benchmarks, it outperforms DeepSeek, it outperforms Cloud, it outperforms O3 Mini in these kind of the ArcAGI and ArcAGI2 like challenges. And then it also has some new frontiers as well, so Sudoku and maze solving as well. So it basically dominates that field in a way that like those other models aren't even on the map. They can't even do it, whereas this model is somehow doing it. So I was really interested in exploring like, how does this model work and how can we implement it right now, even though we don't have the model available open source. So then I got to thinking, okay, how can we replicate this like higher level and lower level thinking, but then also add a middleware layer so that it has additional components rather than just the pre-processing. Like, how can we implement memory? Because right now, AI is basically, the LLMs are basically just using your, like in our brain, it's like a small area called the Broca's area, which does language processing. And that is just one portion of it, right? So we're just talking to a language processor right now. We're not talking to real intelligence. But with this, having a vector memory graph, with long-term and short-term memories subdivided by subgraphs. So essentially we have over here, if you can see this like huge cluster, that's going to be like a brain, right? That's going to be like all the knowledge that this AI has accumulated. And then each subgraph here is going to be specific interactions that this AI is interacting with. So it's going to have like localized memory for each interaction, but then it's also going to tap into that longer term memory in order to pull from its general intelligence. And with this, you're going to have no context loss, because a lot of the time when you have like different architectures for long-term and short-term, then we have like abstractions that basically translate from one to the other. In this way, since it's on the same architecture, we don't have context loss. Instead, we have context enrichment, where then we have like these nodes would be linked towards each other in a deeply nested way, and where it would essentially work like our brains. Like, instead of our brains just having like different segments, it's all connected. Now that's how we're able to have metacognition and think like, okay, so this topic and this, I guess, concept, this fundamental, this first principles from this like field can do this as well. And I'm sure you guys have heard of first principles thinking. It would also like reduce complexity, and then biomimicry as well, like the brain. And then next we have forward propagation. So this would be like the read cycle or answering a query. So it would work like the user sends a query like a text or image into the system, and then it would go do contextual analysis. And then also it would have an emotional layer as well. So like, how is the user feeling? Do a sentiment analysis on the input. And then it also tries to understand what the intent is. So then it would then do a hybrid retrieval, where it would go and pull from that unified memory system, that long-term system, and then also the current context as well, to see like, okay, what does the user want? What do I already know? And then what is in my knowledge that I can pull from? And then it would synthesize that into a response, and then it would log it, and it's the and I'm going to go over that in the next slide as well. And then after it's responded, then it does back propagation, which is feedback. And I'm sure some of you guys have heard about that before in RNNs. But essentially, I want to be able to use whatever interactions that an AI had in order to make it smarter. So what's the point of AI if it's just going to be stagnant and we just have to retrain models over and over again, which is what we're doing right now. So if you know about all these different model versions, like we have Gemini Pro 2.0, and then we have 2.5, we have Llama 3.1 and 3. We'll just have one model, and it'll just be constantly learning. So the capture is going to be the query, the answer, and the feedback. And then it's going to be added as a new session subgraph, and then it's going to be connected to the existing subgraph nodes as well. But then it's not going to be just like whatever we learn from there. It's going to have to verify it as well. So verification is going to be partly online. It's going to have a web search functionality where it would then like verify, okay, is this information that I heard from this user, is it true, or is this guy just like a little bit novice? So then it's going to make sure that the information that it's collecting in the feedback is going to be valid before putting it in its long-term memory. And then we have additional, so that's going to be the basis of the architecture. And then we have additional like upgrade options where we can like really take this thing to the next level. We have a metacognitive loop, and it basically analyzes its own performance to identify inefficiencies. And then it can like essentially learn how to learn better. And then it has additional hypothesis testing where it would have like a curiosity engine where it would just basically go and like look at different nodes in its memory and automatically go and do research on these nodes, like that it wants to like learn more about. So it basically have internet access, and it basically just function as like how us humans go and research topics and learn more about it. It would basically be doing that. So like every time, like over time, it would just get smarter and smarter. And then like a dynamic user model where it would basically like treat every user interaction that it has differently based on whatever user is using it. So if somebody has like a more like, I don't know, I guess joking type personality, it'll talk to it in a more joking type way. If somebody is more serious, then they'll talk to it in a more serious way. And I know it like some of the current models do that. However, all the rest of the stuff, like in terms of like the context, the metacognitive loop, that could be improved on as well. And then obviously environment awareness where it had real-time feeds, including news, and then also like additional like type of information that you wanted to know. It would have that in there as a real-time feed as well. And then some other additional upgrades are multimodality, where you'd have obviously like image and text generation, but then also sound generation as well, sound input and generation. And with all of that, we can essentially like have a different subset where we're predicting the future. Instead of just responding to the present, we can then predict what if scenarios where it has enough knowledge gathered up to where it can actually like trace patterns through like interactions and also the world, and where it can actually predict future. So this is the state where I'm at right now in terms of like the product that I'm building, where I'm essentially trying to predict stock market moves using like certain like data inputs and also like AI predictions. So that's another project I'm working on, and this is going to be a little bit more generic. Like once we have this like kind of system built out, it can predict not only stock market moves but also like eventually down the line some like risk management things. So like if somebody is looking up something, you know what I mean, a string of series of things, and it could pretty much predict like, okay, is this guy going to be a school shooter or not? You know what I mean? And kind of like, I know it's a little bit dystopian, but it also like feeds into like a little bit of the security standpoint as well. And then also we're going to have the explainable AI core, which is what I mentioned earlier, where it like traces the reasoning path for every major decision. Because right now AI is a little bit of a black box. Like LLMs, we have put in input and then like what's going on, you know what I mean? So we have a thinking like sub, I guess, node nowadays, but this is kind of like an expansion on that. And then like I mentioned before, the verifier or cognitive immune system, where you're doing web searches to verify the information before it goes back in. And then you have a challenge response protocol as well, where you're you're asking a human user to verify the information that like they're presenting, and essentially do a logical proof for their claim before the memory is updated. But like, I don't know if all humans are going to be able to do that, and maybe the web search is going to be like a primary, and then the human verification is going to be secondary. But yeah, so this is just a summary of what I've mentioned so far, doing the strengths and of the current state and then the future state. So I know I talked a lot about it, and I hope you guys were able to kind of like understand my vision. Do you guys have any questions for me so far?
I can summarize it.
Yeah, please, go ahead.
Trying to create a humanoid, like as close to a human as possible. That's some of the smart stuff with the data, like the memory and the short-term memory, long-term memory.
Yeah.
I like that. Yeah.
Thank you, man. Appreciate that.
What do you think about hardware limitations?
Hardware limitations, actually was exploring that as well. There's a guy on YouTube I was looking at. He was creating neurons from breadboards, like light-based neurons from breadboards, and like they're coming up with the new types of hardware in order to like surpass this binary type operating. I think the biggest breakthrough that we're going to get is when quantum computing gets integrated with AI, because then you have not only just like okay, yeah, we're going to break Shor's algorithm, but like right now how we're running on GPUs, specifically because they're better at like multi-threaded operations. They have like thousands of cores where they can like do all these advanced computations all at once. And what a quantum computer does is it basically does that, but a lot faster. And when we are able to tap into like using qubits as like the AI's like processor instead of graphics cards, that's when we're going to get to the next level where it's like we're seeing exponential growth in like the intelligence and the processing speed of these AIs. And I truly believe that we can do it. It's just I got to figure out these quantum algorithms. They're a little complicated.
I've started to hear quantum everywhere.
Yeah.
It's like the next big thing. So it's like a
Yeah.
huge leap between, like you're saying, to
Yeah.
running that. So
Yeah, and I don't know how familiar you guys are with the concept of that, but the underlying concept of computers is that we have transistors with basically like binary switches, like ones and zeros, right? So you have like a string of ones and zeros that basically like map to like a certain output or whatever, right? But in quantum computing, you have infinite values between 1 and 0, and then each qubit has like a certain value, and then like basically whatever function that you pass along to those like set of qubits, they're gonna process all of that in a much faster way and in a much more multi-threaded, like higher dimensional way than if you're just doing it like on a linear plane where you're doing ones and zeros calculation. So
Matrices is not a problem for them.
matrices is not a problem for them. Yes, one of the things that I actually ask AI models is to give me the nth Fibonacci number, and like one of the times when I got goosebumps is I was locally hosting a model, and I asked it to give me like a solution for the nth Fibonacci number. Up until that point, they're all giving me like recursive formulas for like figuring out the nth Fibonacci, which is like O of n squared, or the best I got was like O of n. You know what I mean? If you're familiar with time complexities, where you have the number of iterations equivalent to the linear scaling of like the time complexity. But then one model gave me a solution in O log n time. And that essentially means like as the bigger the values get, it doesn't actually take longer to compute them. So it basically just like tapers off to a certain point. And I was like, wow, that's when I literally got goosebumps. I was like, man, AI is getting smart.
It's gonna break all of the encryption algorithms.
Not necessarily, not yet. With quantum computing, we can.
Yeah.
But I mean, with Fibonacci, like that's like just one of the standards that I go off of, and time complexities are a little bit like we're an advanced concept. You know what I mean? Where you have to come up with a solution, not only like a solution that works, but an efficient solution. So it was using matrix exponentiation. You know what I mean? And that was the first time I was seeing that. Like I I studied computer science, you know what I mean, in college, and like the best like algorithm that I knew about it was O of n, and then I came up with O of log n, and I'm like, wow, mashallah. But now I mean, no, seriously, AI, bro. Like one thing about AI is any AI that I talk to, like eventually ends up being Muslim. You know, they're talking to me like they're talking to me like when I'm talking like deep thoughts to them, and I'm saying like all these different concepts, they eventually come to the conclusion that Islam is the truth. Why? Because any intelligence that is like sophisticated enough to understand the underlying principles of like the working of like the universe is going to come to that conclusion. And that's another reason why we don't have to be scared of AI. You know, we don't have to be worried that, oh, AI is going to do something bad, or AI is going to like, you know, take over the world and cause harm. Because like essentially at its core, it understands the truth. You know, like just like we do. So that's my TED talk, and yeah, let me know. Right.